Hi everybody, we are going to continue with selecting and laying out sprinkler heads. Some of the things to consider when selecting sprinkler heads are listed here, but before I get to those, it's important to note that there are a lot of different sprinkler heads in the industry right now, and that's made things easier in some ways because there are lots of different kinds of heads appropriate for different areas, irregularly shaped areas, problem areas, which is nice, but it also means that there are so many choices that it can be a little bit overwhelming. As time goes on, though, and you have more experience designing irrigation systems, you'll become comfortable with certain product lines and materials, and that will make the process a little bit easier for you. Before you get to that point, though, you can keep in mind things like the size and the shape of the turf or shrub areas, as well as whether or not there are any obstructions in the area to irrigation spray, how much water is available to irrigate the area, and what the pressure of that water is, because obviously sprinklers are going to require different amounts of pressure to operate efficiently. Then the types of plants are also going to be really, really important because that can have a bearing on whether you choose a certain type of sprinkler over another, as can the amount of activity on an area. If you were trying to design for a park or a sports field, you would make different choices of sprinklers than you might for a small lawn area that doesn't receive a lot of traffic or play. And then in general, another thing to try to do is keep the number of product types low. That's just for ease of installation and repairs subsequently. If you can keep that number of product types low, then whoever is managing and maintaining the system won't have as many parts and things to keep track of. Sprinklers are classified according to how they're constructed. They're also classified according to their performance and the application of their use. Primarily, they're classified according to how they move or distribute water. And that is the designation of fixed versus rotary head. A fixed head doesn't move, which is exactly what it sounds like, but a rotary head does. And a fixed head will typically distribute water in a fan-like pattern or perhaps in multiple streams that may or may not move, but rotary heads distribute water through one or more nozzles that rotate to move the streams. Other ways that sprinklers are classified include the drive type or the mechanism that causes their movement, the range of throw, the spray pattern for the sprinkler, the arc of that spray pattern, the height of popping up or height of the sprinkler proper, the type of nozzle that's in the sprinkler, its precipitation rate, and whether or not it is set to deal with low head drainage, and I'll talk more about that as we go on. Now, the general classifications of fixed versus rotary are made in this way. Fixed heads are typically used in situations where you need a system to operate at lower pressure, which means it can cover smaller areas. It has varied rates of application depending on the sprinklers that are chosen, and it is the most economical for small or irregularly shaped areas because you can be most efficient in terms of the number of heads chosen to cover those areas. Now, rotary heads typically operate at higher pressures, which means they can cover larger areas and they apply water at lower rates. The ratio of water application with rotary heads and fixed heads is that rotary heads typically, now granted I'm making a pretty big generalization, but rotary heads typically apply water half as quickly as spray heads. So that's something to keep in mind and is one of the major reasons that you don't ever mix those two heads on the same zone. Rotary heads are going to be your most economical choice for large open areas because you can get by with fewer heads to cover the entire area. Now with those rotary heads, they've got different drive types. They are typically gear driven or impact driven with pressure requirements of 30 to 100 psi. and the impact rotates when impact-driven heads, that is, rotate when a swing arm impacts the sprinkler body. And they've got some different adjustments, including horizontal arc and distance adjustment. Gear drive sprinklers typically rotate by use of a gear train in the sprinkler body, and they can have single or double or even multiple water streams. Both of these, whether it's gear-driven or impact-driven, are available as pop-up, but they don't have to pop up. And they also are available with full or partial rotation. Now the range of throw, again, if we're considering the broad classifications of spray versus rotary head, the range of throw ranges depending. With spray heads, you're typically talking about a pretty short radius of throw in the neighborhood of 5 to 15 feet with a flow rate of approximately half a gallon per minute to 4 gallons per minute, depending. And then rotaries have some categories based on their distance of throw, including short range rotaries, so sort of the next step up from spray heads, which range in range of throw from radius of throw from 15 to 30 feet. And then medium rotaries would be those that range in radius of throw from 30 to 50 feet. And then long range of throw or radius of throw would range from 50 to 100 feet with the associated increases in flow rate. Most residential and small commercial sprinklers are either short or medium range of throw, or perhaps spray heads as well. Now spray pattern is also classified into two main categories. There's spray versus stream, and there's also sprinkling or bubbling. Horizontal arc or throw can be adjusted with these sprinklers, and typically there are fixed arc nozzles as well that come in standard degree ranges, so 90 degrees, 120 degrees, 180 degrees, and so on. But with spray versus stream patterns of spray, sprays are matched by precipitation rate so that coverage is uniform. Their horizontal arc of throw can be adjusted using vans or variable arc nozzles. So these have a mechanism on the sprinkler that allows you to change the arc of throw from perhaps 90 degrees to somewhere less or more than that. They've got different nozzles available, including low and high gallonage nozzles. Different angles of spray are also available, so this would be the angle from ground level, which can be important if you're working in an area with windy conditions. Short range streams are typically not rotor driven and would fall more in the spray head category, but medium and long range streams are. Now with the horizontal arc of throw, those can be preset, so it might come with that preset, or you can make it adjustable by changing out nozzles or by limiting the rotating mechanism. There are also those standard angles which I mentioned, and others are available. Couple other notes. High and low vertical angles of spray and even flat spray heads are available. I've seen a few of these out there. They're mainly used for watering shrubs or ground covers, but they can also be useful for turf areas if it's really, really windy. And they're typically installed above ground with a riser or a pop-up assembly. Okay, so moving on. Other things to consider when you're choosing sprinklers for your particular design. The height of the sprinklers is going to be important. In some cases you need to have a pop-up sprinkler, turf areas for example. In other areas though, where you don't need to get that sprinkler out of the way of traffic, you could have non-pop-up sprinklers, shrub beds for example, planting beds. But if you do have pop-up sprinklers, they can range in anywhere from 2 to 12 inches popping up. In turf areas, they're usually around 4 to 6 inches depending. Sometimes you've got pop-ups in ground cover areas and low shrub areas. Those range typically from 6 to 12 inches because with ground covers and low shrub areas, you're dealing with plant material that's taller than turf grass. So you need a little bit of additional height above that plant material to get it adequately irrigated. Now if you're using non-pop-ups, they can be 6 inches high, they can be 12 inches high. They're oftentimes on risers, especially when you're watering ornamentals, because you need to be able to get that water up above the plant canopy so that it's not being obstructed. Now, the idea of low drainage valves. In that case, we're talking about sprinkler heads that have a built-in check valve of some kind, and you see some terms here that I've seen in the industry to denote that. So SAM or Seal-O-Matic, or sometimes I've seen Stow-Matic or Check-Matic. Those are just trade names that indicate the fact that those particular sprinkler heads have check valves built in. And here you see a schematic of a sprinkler head. And let's see, I want to just point out right here it's noted adjustable check valve right here. So this is a valve that is located at the base of the spray body, and what it does is it prevents water from draining out of this head, and this presumably would be a sprinkler head that's low in terms of the elevation of the overall system. But what this check valve does is it prevents water from draining at this head. If you don't have something like that in place, then it's absolutely normal that all of the water in the system is going to drain to that low point, and the pressure will typically overwhelm the sprinkler assembly here, without a check valve that is, and create a lot of ponding or puddling in the area. So they're a good thing to have, at least on those heads that are lower in elevation. Okay, now let's move on and talk a little bit more about nozzles. Nozzles have a number of different features, including the horizontal arc, or are they spraying 90 degrees? Are they spraying 180 degrees? So quarter circle, half circle, so on. What about the vertical angle of throw? They can have a high angle, it can be low or flat. They can have different flow rates, different distances of throw that can be fixed or adjustable. And they can even have different patterns of throw, including some more unusual patterns like side spray, center spray, corner sprays. I'll show you some illustrations of that in a minute. And they can also be pressure compensating and non-pressure compensating. So here you can see some illustrations of basic nozzle angles of spray, including a standard angle, so it's coming up at about 45 degrees from horizontal. Low angle is somewhat below that, and then flat, which again might be a good choice if you're dealing with an area that's got a lot of wind and you're trying to improve your distribution uniformity. And these are spray patterns that can be used in narrow strip areas, so I'm thinking of park strips, places like that. And these nozzles, they tend to be pressure compensating, but you can see that depending on where you place the nozzle in the narrow strip area, you get adequate coverage according to these particular nozzles. Now let's talk about nozzle performance charts, because that's going to be important as you begin actually choosing and selecting product. And I'll go through this looking at an actual chart with you. But the first thing you'll note on a nozzle performance chart is that depending on who the manufacturer is, they're going to have some kind of designation. And it could be a number, could be a combination of letters and numbers. But anyway, that designation or number is going to identify either the pattern, or it might simply identify the nozzles. They need a way to keep track of all their different products, so you're going to see something like that. Let's have a look. So here is just a really general example of what you might see with a nozzle performance chart. But here is, along this left-hand column, is the nozzle name, or in this case number, and that's just designating which particular product is being described. Next, you're going to see pressure listed, and that is the recommended pressure that the sprinkler is designed to perform best at. So if we go back to the chart, so that would be column number 2 here, and here is, let's just look at this top row. So nozzle number 4 can operate at a pressure anywhere from 20 to 50, and there are going to be some associated changes, but that's what that pressure column indicates. Next is going to be radius, or distance of throw. And if we go back to our chart, you can see radius listed here in feet, and notice that as the pressure changes, the radius also changes. And in general, as the pressure increases, that radius of throw is also going to increase. Next will be the discharge or flow is the term we typically talk about when we're considering irrigation design at the given pressure. So similarly to radius of throw, what you find is that, whoops, let me go back. What you find is that as the pressure increases, the flow also increases. So at 20 psi, the flow is 1 GPM. At 50 psi, the flow goes up to 1.8 GPM. And then finally, a lot of manufacturers will note the precipitation rate for their particular nozzles. And again, if we go back to the chart, you'll see that depending on the pressure, the precipitation rate is going to change. And that just depends. So actually, in the case of our number 4 nozzle, if we're looking across here, precipitation rate is listed in terms of inches per hour, and that little box indicates its square spacing, and the precipitation rate does not change, so it stays at 0.12 in this case, 0.12 inches per hour across these different pressures. It does change slightly if they are set up in a triangular spacing pattern, which is what that small triangle indicates. So it does change slightly in that case. Okay, now sprinkler manufacturers will often give you that precipitation rate based on their internal testing. But if you're doing some design work, you might want to be able to calculate precipitation rate on your own for an entire area, right? So you can use some different formulas, and I'm going to show you how to do that now. To calculate for square, rectangular, or triangular patterns, use the gallons per minute of a full sprinkler times this constant of 96.3, and then you divide that by the spacing. So in this case, you've got spacing here and here in between your different rows of sprinklers. And in this case, which is a triangular spacing, you've got spacing here and here to be considered. And I'll show you a couple of examples of how you would use this. Now, if you're considering an irregularly shaped, an irregularly shaped area, you'd want to use the gallons per minute of all the sprinklers, and I'll show you how you do that as well. And that's what I'm indicating here, actually. So this obviously is not square or triangular or rectangular spacing. So the formula is very similar. The only difference would be that you sum the flow for all of the different sprinklers in the area. Okay, so let's look at a couple of examples. In this first case, we are going to consider a field that's receiving 315 gallons per minute, and we happen to know the dimensions of the field. So how would you utilize those formulas? Well, you would take our constant, which is 96.3, times the flow, which is given as 315 GPM, and divide that by the area that is noted above. So this 59,400 is simply 360 times 165. That's where that comes from. And what you end up with is a precipitation rate of 0.51 inches per hour. Now in the next example, you're given the information that the heads are square spaced, they're 12 feet apart, and that each of them has 2.6 gallon per minute flow with, and that they all have a full circle radius or arc of throw. So the way that you would perform that calculation is using our constant 96.3 times the 2.6 GPM, which was given, and then dividing that by the spacing, which was also given, 12 by 12. So you end up with a precipitation rate of 1.74 inches per hour. Okay? In both of these cases, you're essentially dealing with square or evenly spaced heads, but you very often may be dealing with a situation where you have an irregularly shaped area. Now in that case, let's consider this example. So a 60 by 15 foot area with 6 heads that are half circle, having a flow of 1 gallon per minute each, and 4 heads that are quarter circle, having a flow of half a gallon per minute each. So how do you then use that formula? Well, you start out again with the constant 96.3, and by the way, this constant just helps us get from the units we're working with in the problem to units of inches per hour. That's what this is about. Okay, so 96.3 times 8, and if you recall, let me back up here, in the case of an irregularly shaped area, Q is summed up for all the sprinklers in the area. Okay. And we know from the given information that we've got 6 heads that are 1 gallon per minute each, so that's a total of 6 gallons per minute. And we've got 4 that are half a gallon per minute each, so that would be 6 plus 2, which would give us a cumulative flow rate of 8. So then you just put that into your formula. You've got 96.3 times 8 GPM divided by 900 feet, which is the area here, and that equals 0.86 inches per hour. So those are ways in which you can calculate precipitation rate without relying completely on manufacturer specifications or information. Now let's go look at this example that we've been using throughout the class, and I want to point out a couple of things here that relate to selecting sprinkler heads. So in this example, we know based on information we're given that the length of this particular area is 81 feet and the width is 12 feet. So you might look at that area and think, all right, 81 feet, that's really, really big. But the width of that area is only 12, so fairly small. So even though it is quite a long area, it's pretty narrow. So it's not likely that I would be able to irrigate that area efficiently with rotor heads. It's more likely that I would choose spray heads so that I could minimize the amount of overthrow onto either the parking area, the sidewalk, and the street. On the other hand, over here in this area, this is about 54 feet long here in this direction and about 32 feet wide here. Now if you think back to how the different sprinklers were categorized and classified, recall that the small rotors were appropriate for areas from 15 to 30 feet in width. And so mediums, I believe, were 30 to 50 feet, something along those lines. And so my point is just that for this area that is a little bit wider, small or medium-sized rotors might be appropriate. And if you're considering how to select and lay out heads, you'd go through your whole base plan in this way and say, all right, here is an area of turf that's also long and narrow, probably going to use spray heads to avoid overspray. Same train of thought on this side as well. And then as you get into the back, you've got another wider, more open area, so rotor heads are probably appropriate. But you've also got some areas with small planting beds here, small planting bed here, some hedgerow type areas here and here. So you have to consider which choices are going to be most appropriate for those areas. And you need to consider things like the fact that you've got some trees that are existing that might be obstructive, but that's all to be considered. So the next step then would be to sort of just lightly outline the areas that you think you're going to be able to irrigate in certain distinct ways. So you can see here in this back area, they've designated it to be irrigated with rotors, which makes perfect sense considering the size and shape and the fact that it's a turf area. Here in this long narrow turf area, they've said spray heads, here as well, here as well. And then they've also designated spray heads. Even though this is also part of this larger turf area in the back, they've designated spray heads here because it's sort of a small, odd-shaped area, and they're going to be able to be more efficient with spray heads there. They've also noted shrub sprays in this area and shrub sprays in these two areas and shrub sprays in these areas as well. So this is the process that you would go through to start helping you select sprinkler heads for these different areas. Subsequent to that, you would start looking at what's available from the different manufacturers, And you would go to the next step of locating and laying out sprinklers in your different areas. And these layouts are going to be based on the sprinklers that you choose. Yes, we said in broad categories there were going to be rotors here and spray here and spray here and so on. But you're going to want to be looking at actual product information and making decisions about what products could work for you. You're going to look in particular at this point at radius of throw. So is the spray from here going to reach all the way to the next one and vice versa? How about over here? Is the spray from this sprinkler going to reach all the way here and vice versa? And you're going to be deciding on which sprinklers make the most sense for these different areas. Just a side note here, this particular legend in this case denotes that circles indicate spray nozzles, hexagons indicate rotor nozzles, and then the amount of shading in those indicates whether they are full circle, half circle, quarter circle, and so on. They have indicated shrub spray nozzles with squares in this case, so that's just for point of reference. Alright, so that's the introduction to selecting and laying out sprinkler heads, and you have an assignment based on that, and I will look forward to receiving that.